All right, welcome back. And now we are going to look at another example where we still have to find a polynomial function, but now they want a specific one. So they're going to give you a little bit more information in order to figure out the exact polynomial function that satisfies all those requirements. What are the zeros and what is the actual function values that it has to pass through? So we do want a polynomial function of degree 3 with real coefficients that have the following conditions. So it has zeros of 4 and 1 plus I, and it has to have a function value of 4 when we have an input of x equals 2. So let's first start off with our zeros. So remember, when we have a complex zero, what else do we know? We know that its conjugate is also a 0. So 1 minus I should also be in there. So let's start. Now, we want to have 4 be a 0, so we know that x minus 4 must be a factor. We also have our complex zeros, so again, we got to write it all out. So we'll have the first one and the second one. Now, in order to account for all the possibilities, remember we can multiply the whole thing by a constant. Let's just call that constant A, and we'll worry about that later in the problem. For now, let's kind of simplify all this business going on. Now, we said before that we got to take care of the complex stuff first, so let's do that. So we're going to move our parentheses and distribute. We'll move our parentheses and distribute. And now we can do a little foiling. So we have our x plus minus 1s that we're going to square. Our inside and outside cancel, remember. So all we have left are just the lasts. So that's going to be a minus I squared. And now we can go a little bit further. So let's FOIL that out. We can change to all parentheses now. So our x minus 1 squared is going to give us our trinomial here. And then remember, I squared is negative 1. So negative negative 1 becomes a positive 1 at the end. And so that will give us an x plus 2. Or excuse me, a plus 2 at the end. All right, so now we got to go a little bit further with all of this. So if we FOIL all this out, so x first, so we'll get x cubed minus 2x squared, and then a plus 2x. And then if we multiply the negative 4 in, so negative 4x squared plus 8x, and then a minus 8. And so let's go over here now. So f of x is equal to a times x cubed. And so we're going to have a minus 6x squared, and then a 10x, and then a minus 8. All right. So there's our polynomial function generalized. We now need to make it specific to satisfy this, this function value. So how do we do it? Well, if we know that f of 2 equals 4, we should be able to plug in 2 for all of the x's, and we know that the final outcome better be 4 at the end. So let's do that. So if we said f of 2 is equal to a times 2 to the third minus 6 times 2 squared plus 10 times 2 minus 8, that should all equal 4. So now we just got to break all this down. So what do we got? We got 8 minus 6 times 4, which is 24. 8 minus 24 is negative 16. Negative 16 plus 20 is 4. 4 minus 8 is a negative 4. So this looks like it boils down to a negative 4a equals 4. So a must equal negative 1. So our final answer, after all of this, should be f of x equals a negative of what we had in parentheses up here. So let's distribute the negative at the same time. So there should be our polynomial function. So there's a lot of layers to that one. I mean, obviously the big thing is just breaking this all down correctly and just being very careful with the algebra on all that. But once you have that broken down and have that general polynomial, then you can satisfy the specific condition that's given to you. So, all right, well, we'll see more in the next video since that was a long problem. So stay tuned.